Welcome to our next second webinar session titled More Efficient and Sustainable Construction Sector by the BUILDCHAIN System. Today we'll be talking about BIM-based management and construction economics, business models, and the whole series is part of our BUILDCHAIN project, where we are up to upgrading knowledge assets and BIM for safe, sustainable, and resilient European construction. So just a short introduction. We are all aware of some of the interesting things going on at the moment in the construction industry. So among other things, we are facing significant challenges in sustainability and economic efficiency, despite the actual use of building information modeling, or BIM. There's a lack of effective BIM-based management strategies, and traditional construction business models are inadequate in integrating sustainability practices, creating need for innovative business models to balance economic feasibility and project performance. Therefore, exploring the potential of BIM-based management and innovative business models is critical to driving sustainable construction practices and economic efficiency in the industry. So what you'll learn today in our webinar, we'll try to answer some of your questions related to what the intelligent BIM solutions are. How does a true platform for lean construction management work? What are the main benefits and challenges of 5D BIM implementation? How to improve efficiencies in construction projects using 5D BIM modeling? What methodology approaches can be used for development of business models for complex technology ecosystems? And also what the 360 business model evaluation BME tool for quantitative assessment of business models and identification of win-win situations are. We will have three presenters with us, but first let me start with presenting our hosts. So Milena and Anna, thank you for taking care of all the technical stuff. And again, Noemi is with us, Noemi Friedman. She's a senior scientist from Staki, Institute for Computer Science and Control from Hungary. She's the main initiator of the BUILDCHAIN project. Noemi earned her PhD in civil engineering, but since then she has shifted her skills to stochastic computations, data science, and machine learning. So her main research focus is to improve engineering simulations and decision-making processes by using measured data. She has a demonstrated history of working in the cross-disciplinary fields of computational science, artificial intelligence, and civil engineering. So thank you, Noemi, for being with us today. And now let's hear—
Thanks, Katja, for the introduction.
So let's hear our first presenter, lecturer, Mileta Pejovic. He's a senior BIM manager from Bexel, one of project's partners from Serbia. Mileta is a senior BIM manager and product specialist at Bexel Consulting. He has deep and all-around experience in BIM on all levels, focusing on open BIM workflows and the integrated BIM project management. More than 10 years of working experience in BIM implementation and more than 50 projects all around the globe, in Europe, the Middle East, and Central America are behind him. So he's also an associated lecturer at elective course BIM 2 of the Faculty of Architecture, University of Belgrade, and the member of Building Smart International Professional Certification Program Development Group. So we are very proud and honored to have an opportunity to hear a lecture from Mileta, and you are very welcome to pose your questions into the chat box, and you'll also have, all the participants will have a chance to pose the questions to the lecturer right after his presentation, and also at the end of all presentations we will invite you to the discussion. So you are welcome to think about the things that you would like to, any questions you would like to raise. Mileta, the stage is yours.
Thank you very much. It was really nice introduction. I will try to share my screen. and then start with the presentation. Can you just confirm that everything works fine?
It's great.
Okay.
We can see your presentation.
So good morning again to everyone. My name is Mileta Pejovic, and I work, as mentioned, as a senior BIM manager at Bexel Consulting. And on behalf of my colleagues, Igor Osmokrovic and Jelena Petrovic, who will closely work with this group on the project, I will introduce you with our company and to our integrated BIM management platform. I will point out major features of our Bexel Manager application, our current integration with other, let's say, open BIM systems, and also give you some ideas and possibilities for the future integration and uses of our BIM platform for information exchange, project information management, cost estimation, scheduling, and even digital building lifecycle. So at the beginning, just a few words about our company. Bexel Consulting is software development and consulting company. We are specialized for BIM in construction, and we are in this field of industry for almost 2 decades with a vast experience in BIM implementation, collaboration, management, and software development. And our company, as mentioned before, is also a multinational member of Building Smart International. And I might say that we are really dedicated and passionate to integrated BIM project management, BIM education, and innovations in this field. This is a small slide which presents, let's say, our worldwide presence in a very diverse and different types of projects. Also, you can see a very diverse client base of our clients, which includes designers, project managers, contractors, and also large investors. And our clients are using not just our consulting services, but also our BIM platform as well. And this is just a part of our clients listed in the slide. So let's start with a real presentation and the main challenges in the industry. So a major challenge in construction industry today is mainly fragmentation of project management workflows. And it means that we have a different sources of information. And when we talk about information, we mean all type of information. This information have multiple revisions, different way of classification or sorting, different types. Also, even if we have the accurate information properly organized, it's very important that the information can be verified and also delivered on time. So all these aspects must be, let's say, in line. And the current industry workflows are fragmented and limited in interconnection. So this leads to, in the first place, inefficiency, because everybody's working its part of the project management from scratch with a little data input from a previous stage, or even if the data is delivered, in most cases, its usability is questionable. You need to double check this information and then do confirmation or to redo if the information was not accurate. It's often case information is even in a wrong format, so it's not machine readable. So it lacks automation in a way, or simply the information are not verifiable or even traceable. And this is typically the characteristic of non-BIM centric project management. It's related to traditional project management. So solution for this is BIM-centric project management. And in BIM-based project management, the process is integrated in terms of workflows and in terms of information source. This means that every stakeholder speaks the same language and all project data is transparent and traceable, and participants could rely upon information delivered by other teams. Of course, prerequisite for this is standardization of the data and data exchange, of course. And this is where open BIM standards and projects such as BUILDCHAIN takes place and make this concept a reality. So this is a general ecosystem of our software solution. where we try to implement BIM-centric project management. And in centers, we have integrated our expert BIM management platform that includes different modules or data domains for managing the project in various stages of its life cycle. Also, our platform allows high level of automation. So all presented workflows in these slides are automated in order to allow more efficient and higher quality of output data. So then we have a range of cloud-based solution. You can see them on sides in a lower part of the screen and also on the right part of the screen. And these solutions are integrated in one common data environment platform to improve collaboration and data exchange between all participants of the project. This allows seamless flow of information from expert tools to the stakeholders, and the same thing goes in reverse way from stakeholders and construction site back to the managers in the office. Also, to allow knowledge exchange, we have a knowledge database containing numerous predefined templates for different purposes. And this enables further improvements of our workflows by sharing knowledge between teams. So not only exchange the project data, but also exchange of knowledge, templates, rules, configuration documents to improve efficiency. And also you can reuse these predefined knowledge-based templates on different projects, which are similar or which using the same, let's say, databases or standards. Also, another important thing is that our open API or application programming interface enables integration with third-party solutions, such as external database and ERP systems, for example, and that could be incredible valuable resource initially developed for workflows that are outside of the just construction management domain, but could be very important in the process of improving overall efficiency of the construction industry as well. So in the following slides, I will show you some of the workflows and functionalities of Excel Manager platform and explain how these features are integrated with cloud-based solution. Using this approach gives us ability to review and share BIM projects using online common data environment. And the current video presents different use cases, but the most interesting thing is that easiness and freedom to exchange and provide different results of previously, let's say, performed analysis into interactive Power BI reports. This can greatly improve your workflows and increase efficiency and collaboration between different project stakeholders. And also presented and interactive dashboards can be generated for any project in any, let's say, project stage, starting from initial stages through entire, let's say, life cycle of the project. This process map explains the automated process for collision detection. So we'll start from the beginning. So starting from federated BIM project, which is fed by predefined standardized templates for creating clash detection groups on one hand, and on the other hand, templates for creating clash detection configurations or rules, how these groups will be checked one versus another one. All found results are saved once you actually execute the clash detection analysis. All results are saved and can be instantly and directly exported into different types of reports. This could be PDF, Excel spreadsheets, or interactive Power BI dashboards again. And this is how it works in reality. In the early project stages, one of the most important things in project coordination and collaboration of all project trays, and therefore clash detection analysis performed on projects are extremely valuable and important. And our workflow allows almost full automation by using customizable templates for performing clash detection process. These templates are created from Excel files mainly, and process starts with importing groups of elements that shall be used for clash analysis. These model groups can be made automatically from rules, or you can make them manually. The next step is importing clash detection rules. Again, these are from Excel templates, and once you let's say, import these templates, the system can run and execute clash detection analysis, and all identified collisions are, let's say, created, and you can organize these results of clash detection analysis in a different ways. These results can be grouped differently, and also they could be exported in a different ways. Again, as I mentioned previously, you can export results in a way of Excel spreadsheets, but more importantly, also as an interactive Power BI dashboards and directly to our online Bexel Manager viewer. So these results can be analyzed remotely by using any mobile device. So practically from any place, anyone who is using mobile device, using web browser, can access these results and review and analyze these results on their mobile devices. So the next step is data verification, which is a very important process for quality assurance in all project stages. In this case, BIM checks can be performed based on customized or standardized information delivery specifications. And again, we prefer ideas based on the Excel spreadsheets because it's very simple, easy to understand for everyone, and you can easily edit these Excel spreadsheets. The system will go through multiple rules and find issues, all elements, 3D elements which are not in compliance to requirements which you previously defined in these Excel templates will be organized into different groups based on the issues that are found, missing or inaccurate properties, attributes, classification, materials, and so on. And then all these results can be sent to BCF issues or exported directly to Power BI reports. The process starts again with a BIM data checker. And when we load predefined requirements in form of Excel file, the system will analyze all BIM elements, find inconsistencies, and then create results. Also, to be fully machine readable, these predefined rules can be loaded from JSON files as well. All results and elements that are not in compliance to requirements will be grouped in different groups based on these issues, and then we can decide how these issues will be reported and coordinated with other stakeholders. As I mentioned previously, we can send BCF files or BIM collaboration file formats, Excel spreadsheets, or Power BI dashboards. Or again, we can just send these issues directly to our online 3D model viewer, so anyone who is using mobile devices can access and see these results of analysis. Even if the model is missing some required properties, or if values of properties are not accurate, we can use another feature of the Bexel Manager to automate the process of adding new properties. So model can be enriched from different data sources. We prefer to use customizable Excel templates because these are, again, simple and easy to edit, and also easy to understand. And however, using our API, we can connect to external databases as well and add new information and property sets to BIM element. All properties, no matter if they are original or added, can be saved within the model or exported into IFC files or into Excel spreadsheets as well. So it enables almost seamless information exchange. So this video shows how we can automatically add new properties from Excel templates. In short, using Excel files based on existing properties or attributes of 3D elements that are specified in the first columns, we can set the rules. So basically, these first columns are rules, and existing property values will be interpreted by the systems. So the system can create new properties and different property values based on these existing rules that we define. In these examples, we are adding missing cost classification codes and description to all BIM elements. In our case, we performed automated data enrichment by simultaneously adding uniformat, uniclass, and DIN 276 classification codes and descriptions based on available element types or IFC entities and some existing rules. once we, let's say, run this add-in or the application, the system will add automatically all predefined, let's say, properties to all existing 3D model elements. And then once these properties are added, we can use these newly added properties or their respective values to color code elements based on these values. So it's again gives you another, let's say, level of flexibility, which you can use to differently color code and visually present different properties or different values of properties to each element. Any user now can easily access or edit these templates or values of the properties and adopt them for different projects or use for different standards on the different projects as well. So in this video, a different approach is shown using our API. Instead of using Excel spreadsheets to automatically add all different types of properties, we are using this template to add just one code. And the API application that we developed can connect to an online database. In this case, we are connecting to Building Smart Data Dictionary and download all necessary properties based on the existing one. And the existing one is the matching code, which will be connecting to the database and download all relevant information for that specific code. And once these properties are downloaded, you can see that all these additional properties downloaded from the external or online database are added to each 3D model elements. And now we can easily explore or even again color code these different properties or values based on, again, based on downloaded values of these properties. The system shows us now how we can easily explore different properties and different properties values using our Bexcel Manager viewer. As you may see, the different types or different IFC entities are downloaded different property sets which are used to analyze or calculate different aspects of that 3D element. You may see that windows and doors have different types of properties, unlike, for example, floors and other types of the elements. Again, all of this is downloaded from the online application or online database. The similar method as shown in the previous video can be used for connection to any online database, for example, to Digital Building Logbook or EC3 or Embodied Carbon in Construction database. Using our API, it's possible to develop an application that can download existing online data and use it to add additional properties or even to calculate carbon emission or, for example, using available material quantities from the model, we can multiply these quantities with information which are downloaded from the EC3 database and calculate the embodied carbon in construction. Also, results of these analyses can be saved and added to 3D elements as calculated properties or also exported into IFC files or Excel spreadsheets or even Power BI dashboards. So this is just an idea how the system can be used and utilized for different purposes. This process map shows you another workflow for cost estimation using Bexcel Manager, and there are two main approaches to fully BIM-based quantity and cost estimation in our platform. One is fully relying on information based on 3D element models by creating custom work breakdown structure based on available properties of 3D elements. And once the system automatically creates breakdown structure and cost items, we can then edit all created cost items and additionally assign resource information and cost information and apply the entire cost estimation to automatically calculate bill of quantity. The second approach is using existing cost classification or standardized databases, which can be imported into Bexcel Manager. These databases could be created within the Excel spreadsheets, or they can be again, using our connection with the external databases, can be downloaded from external databases and import it into our system. Once we have the cost database with specified unit prices and resources, we can link these cost items to 3D elements. Again, that could be automatically done or manually, depending on the rules that you are using. And then the system can calculate the quantity and price, and then you can use results to the further, let's say, steps of the process of project management, for example, for scheduling purposes or creating cash flow, or even just simply export all results of analysis into, again, Excel spreadsheets or Power BI reports. Since we are time limited, I will just skip to the next group of BIM features that are 4D or scheduling features. And Bexel Manager is a real scheduling and planning platform that also visualize created schedule as a construction simulation. So even though these could be performed as a separate 4D analysis, the most effective workflow is to perform as an integrated 4D and 5D BIM process in combination with cost estimation. This video is just showing some of the project examples and schedules which are created entirely in Bexel Manager. So you may see a variety of project types in their size. And also I can assure that it's used and it can be used for scheduling of different types of projects, such as residential high-rise buildings, sport venues, hotels, industrial facilities, or infrastructure such as tunnel, railways, bridges, and so on. So using this unique Bexel scheduling engine that combines planner's logic and model information to instantly generate entire schedule, it starts with the planner when he specifies spatial zones from existing 3D model and organizes relations between these spatial zones. The next thing is to create work sequences and make relations between different groups of works as they are defined in the cost database. And here you may see how these relations between different work groups are created. Once we have this, the planner can make a schedule hierarchy and templates which can organize and mix these zones on one place and work groups on the other place, and the system will intelligently generate tasks and relations between these tasks. So this is a result of created, let's say, automatically created schedule. And another benefit of this approach is that the schedule is automatically linked with the cost information if you create it this way. Also, it's location-based, so you may see the line of balance automatically, and planners can easily evaluate and optimize entire cash flow using this approach. User is then able to analyze schedule in line of balances again, and a Gantt chart view. Since the schedule is created in this way, automatically linked with the 3D model elements, and again, with the cost information, the complete analytics of the project is available. So planner can easily evaluate and optimize all schedule parameters. And also all these available results or data analysis can be exported into Excel spreadsheets or again into interactive Power BI dashboards. And of course, you may see or analyze construction simulation as a video. So finally, with the facility maintenance module, Bexel Manager also covers 6D BIM functionalities, including asset management, reporting, cloud-based document management system, and facility maintenance planning. And in the least, let's say in the latest release of the Bexel Manager application, the entire facility maintenance module is web-based and entire data is cloud hosted. So all created information are synchronized and updated between this cloud-based application and remote Bexel Manager facility maintenance module. So connection between facility maintenance and 3D elements is interactive, and the user can easily find all assets that are related to specific activity or important to specific work scope. And also related documents can be added and embedded basically to the project. So anyone who can access to the project using mobile device can access not just the facility maintenance plans or activities, but also the documents which are related to it. And also they can see the 3D elements or assets which are related to these facility maintenance activities. For the end, we believe that Bexcel Manager presents a true platform for a lean construction management. It's open, integrated BIM solution that covers wide range of BIM functionalities throughout whole project life cycle. And the major principle of our platform is that change in one place is reflected throughout entire BIM project. This establishes a single source of truth, credible, centralized database upon which all stakeholders can rely on. So that would be all from my end. Thank you all. If you need additional clarification, what we do or what our role on this project is, I would like to remind you once again that my colleagues Igor Osmokrovic and Jelena Petrovic will be closely working with this group on the project, and you can reach them for more information. And also, if you're interested to Bexcel Manager, I can advise you to visit our webpage and our YouTube channel, since we have many available webinars and use case videos for different projects.
Thank you very much, Mileta, for this great presentation. And I'm inviting, if there are any questions, any participant who would like to, you can pose it in the chat box or just raise your hand. That's at the bottom of your screen, right next to the screen share screen button. You have record and then raise hand icon. So you are kindly invited to pose your questions. So since at the moment there are none, Milita, I have a question, you know.
Okay.
So do you know why did the construction company switch to using BIM? It's a joke, you know. I'm joking again. I do that a lot. So, you know, yeah, I was reading why some of the construction companies switched to BIM, and they explained that they heard that it's a great way, you know, to build a model career. Well, I'm joking. At the moment, we don't have any questions, but maybe there will be some at the end, Mileta. So thank you for now. I would also like to invite all the participants to visit BUILDCHAIN project website, which is www.buildchain-project.eu. And you're also invited to participate on the social media of the projects, where we are trying to spread the information on what we are doing, what the research is all about. So you are very welcome to join us there. Our next presenter is Jan Slobodnik. Hi, Jan. He's head of the head of the BIM department at Protim Ržišnik Perc from Slovenia. This is the great company where they are doing the independent consulting and also design. It's a design company. So the main mission of the interdisciplinary team of architects, engineers, and other experts is the implementation of advanced BIM technology and processes to provide more accurate and detailed models, enhance the quality of the built environment, and create a shared understanding of the project outcomes among all stakeholders. This is a great mission statement. Jan, the floor is all yours, and expect the questions at the end.
Great. Thank you, Katja, for the great introduction, as if you had it prepared already. Let me share my screen. I hope it's already popping out.
Yeah, we can see you great.
Okay, awesome. So yeah, on behalf of my company, Protim Ržišnik Perc, I will talk more about BIM-based economics of construction, so the 5D dimension. But before I start with my presentation, I just kind of wanted to start with the basic question: what is BIM? Because as figure indicates, BIM means different things to different professionals. Some say it's a software application, others say it's like a process for designing and documenting information. But in my opinion, I believe it's more or less a holistic approach to design, construction, and maintenance of a building. It is, of course, intertwined with technology, both hardware and software. And as the technology evolves, BIM will evolve with it. Hopefully, with today's presentations, you will get a better impression of what BIM means in practice. According to BIM fundamentals, there are 7 recognized BIM dimensions. First, we have the 3D modeling. This is the basic one. This is the one that allows us to view project digital model and its geometrical and graphical information in 3D. Then we have 4D, where the elements of 3D models are linked to the execution timetable. These 4D models, they can be created either by adding construction time information to the particular object or by linking existing separately elaborated schedules to the models. Then we have the 5D BIM, which is regarding the quantity and cost estimate. And this will be the main focus of today's presentation. We have also 6D, which is associated with energy efficiency, sustainable development of new or existing buildings. And 7D, which is the operational management and maintenance. In addition to this 7 dimensions, there is also like an open debate on 3 additional new dimensions of BIM, such as 8D, 9D, and 10D. They are regarding safety during construction design and construction. Then we have the lean construction and of course, construction industrialization, which BIM allows. If we jump back to the 3D modeling, as you know, during the design phase, there are several models created from different disciplines. In our case, in our pilot project, new hospital building in Slovenia, we'll mostly work in Revit, where we will create architectural and structural model all in one, but with different work sets. Then we have installations, modeling installations, which will be done in, again, separate models for, let's say, for plumbing, for heating, for ventilation, for sprinkler systems, and they will all be joined in one federated model, all together with a steel structure done by structural engineers in Tekla structure software, and at the end added to architectural model. The most important fact here that should be highlighted is that we work and communicate through BIM models. So this information exchange, this can be done using or communicating inside the actual software that we are using for modeling, but we are also, of course, using other cloud-based solutions that are on the market right now, such as Navisworks. Now we have added Bexel to the list, which I'm really happy about. There's also other software, commercial software solutions that are on the market. But what is the most important part is that all this information exchange is done by using vendor neutral formats. Here I'm talking about IFC format, BCF, COBie, and others. As you all know, project goes through several project phases before it's being handed over to a new owner. And we kind of think that real BIM usually starts at the end of pre-design phase, when, let's say, a master plan and an estimation of the value of constructed object has been confirmed. So in conceptual design, we perform the first cost estimation from the models. This is mostly done by measuring the building floor area. So the unit is square meter. In preliminary design, the cost estimation is done by extracting information from the actual building elements. So we add volume, another unit to the list. As the project progresses, so we are now, let's say, in detailed design phase, the models get enriched. And for that reason, we can prepare the cost estimation also based on not only the dimensions of the actual elements, but also on their units, costs, on their length and other things. After the design phase is being finished, we can prepare the final price bill of quantities that we in the end share with the vendors, different vendors, in the tender phase. And based on that, we collect the data, we collect the list of contractors that will work on us with the project. And if we jump to the construction phase, our cost estimation doesn't stop here. We are monitoring all the monthly situations and all the changes in cost, this regarding materials, equipment, transport, and all other things. So to summarize it, BIM allows us to manage project costs from initial conceptual designs all the way to the end of the project, to the final invoice, which is really crucial. Regarding classification system, there are already many classification systems established in the world. I've listed just some of the most commonly used in the construction industry. You're probably aware of all of these. EU-funded, for example, is the one that's used in early design, like for preliminary cost estimates, cost comparison, and analysis. And it really provides like a quick way to see unit prices, and it's used for square foot estimation. And then we have master format done in the United States. This is used in the later stages of design and execution, and it mostly concentrates on materials and installation. Then we have what is important to notify, it's that uniformat and master format, they can all be used together, but there is no one-to-one relationship between these formats. So let's say the grouping is different, subgrouping is different, and the codes are different. But if we use them separately for different elements, such as Mileta showed in Excel software, we can do this. Then we have OmniClass. This is also from the States. This provides more detailed information than uniformat and master format, and it's mostly suitable for information exchange and collaboration between the participants. It's also integrated in Revit, for example, which is a nice feature. The next one is UniClass. This one is European. It's done in United Kingdom, and is together with OmniClass. It's also compliant with the ISO 12006 standard, international standard for building construction. Here I also listed there are a local classification system existing. So, for example, Czech Republic is one of them, when they have different classification system for different regions. And when this is not enough, companies take another approach, which is creating their own company-specific standard. And this is also kind of part of what we will do in BUILDCHAIN project as an industrial partner. So if I explain it a bit better, like for example, our company already has a work item catalog, which has the most usual work items used in estimates. And these work items will be structured using our own classification. Of course, we won't start from scratch. We're already used some classification systems created and shared on the market. So our system will be based on standards such as DIN 276, ENURM from Austria, and also the standard that our Slovenian Chamber of Engineers is just preparing just right now. It's not being published, but we are being part of it, and we see that there are also connections with our system that we are developing right now. What is important to emphasize that classification hierarchy will be following technological stages of the building. So let's say we have construction preparation, such as like site layouts, construction pit protection, and other things. Then we'll have earthworks, demolitions where needed, foundations, building the structure, the execution of installations, execution of craft works, let's say partition walls, plasters, flooring, and in the end, like finalization of the installations. Once the database is set, we need to create the connection between the work items and their cost. Here I'm showing an example of pocket foundation, which includes 3 different work items. In this case, formwork, reinforcement, and concreting. Every work item is connected with the cost database that contains material information and pricing, and also the actual activity. In this case, it's the work from the construction worker or professional worker there, or coordinator, let's say. This is really crucial to understand that the cost database is not only aligned with the material cost, but also with the actual activity on the site. Oh, sorry about that. So development of BIM model will be in line with the project cost management based on the connection of price bill of quantities with individual building blocks. So in this case, if, I'm showing our company classification system. Of course, it's still in development, but just to get an impression, this one will be enriched. So the model that we see in the middle will be enriched with this company classification system. The particular elements, in this case, is the walls, will get assigned specific code from the company classification system. The software will recognize the quantities, and based on our company cost database, which is also imported in the platform, will tell us the exact expense or price unit for this particular elements. And in the end, of course, we have the price bill of quantities ready and shared with the investors and with the contractors in the tendering phase. Let me talk a bit more also about the main benefits of the cost estimation or 5D BIM. Like the biggest benefit is of course having more accurate information about estimated costs and costs occurring on the site. We have unified data structure for BIM. 5D BIM can also improve the information flow, like since the most of needed basic information comes from the model itself. And because most of the costs are based on the objects, quantity changes can be easily identified when the design model changes. The last thing is that cost analysis can reveal the cost impacts of different design proposals. And like when multiple cost analysis data is collected, it can be used for creating ranges of likely outcomes and benchmarking. Of course, with benefits, there are also challenges. The first one is having standardized, clear and precise modeling rules for BIM models. To define this, of course, you need to create like a knowledge database that you share with your coworkers, that they don't like errors such as, I don't know, incorrect type of or material designation don't appear, or like duplicated or overlapping elements in the models are not existing. We also need to define and assign different level of detail to individual stages of the project documentations, because models get enriched with every project phase. The second main challenge is unified classification for BIM. So this is for national and international level. The problem is that a lot of classifications now being used on the market are still underdeveloped for some of the groups of building parts. Also, not many classifications have been extended to the nearby markets. Let's say the UK, they created their own classification system, but has never been used in Slovenia, for example, or at least has never been shared to the public. Which is also important, that the classifications, they shouldn't be specific to the project. This applies in particular to underdeveloped classifications, where you're kind of forced to add new number code. And therefore you have to be really careful that you update this database once the project is being finished, because that means that if you don't do that, you can use the same code system for different work items, and then in the end you don't have it. This standardized process collapses. The last thing that I want to mention is the creation of cost database. This is created following the index prices for the materials and building elements, and also performing pre and post calculations for past and future projects. In the end, I want to point out some of the considerations and recommendations when it comes to 5D BIM. So you have to understand that BIM is not only meant for viewing or graphical representation. So it must be made with the purpose of reusing this information downstream. So every modeler, every project designer, they have to understand why they're using specific standardized workflow, standardized libraries, and so on. what is also important, we need database maintenance. So it's not only enough to create this database, we have to update it with every next project that we create. Also, one of our recommendation is that cost data should be connected, shouldn't always be connected to each layer of the element. Let's say we have a partition wall. We should let's say we should consider this partition wall as a work item, as a unit, and not as element which has 4 layers of plaster wall plus studs plus connection plus plaster. Because if you consider it like this, the standardized way of extracting this information for the model would be extremely difficult. So we consider plaster wall, a specific type of plaster wall, as one unit, and this unit has only one specific price attached to it. We also have to consider that BIM model is not the whole truth of the project when it comes to concerning costs. That's because not every part of the cost of the project can be linked to the building objects within the BIM model. This is because like all materials are not modeled, for example, such as mortar, I don't know, ceiling foam, parts of insulation, fittings. Also, some activities have no relation to the components modeled in BIM. Let's say excavation, installation of cranes, construction site urbanization, and others. So it's really necessary to add this information, this remaining information, either manually or to calculate it from other documents. I also mentioned that the breakdown of cost analysis should be at the appropriate level. This means that it shouldn't be too complex nor too simple. And what is tying all this together is learning by doing. So like with any novelty, new implementation, it is almost impossible to always make the right next move. But by having these projects being done, by learning from our mistakes, by learning from other people, from good practices that we see in the market, there's a greater chance that we will also succeed in our process. And with this, I would like to end my presentation. If there are any questions, I'll be more than happy to discuss it.
Thank you, Jan, for this really great presentation, and also with the inspiring end for working together. We do, however, have a question from Jerne. Can I just read it out? Let's see that one. So you have your company database of construction costs that you update it regularly. Is there a common national database of building costs that could be used instead? Should I repeat, or did you understand?
Yeah, there are some costs that are already being defined and shared also in the national level, but it's not the problems we have here is the connection between the cost and the actual cost of the material and the cost of the activities. And this is something that we can't really standardize in a way that it could be implemented in BIM, because usually these standards, as also ICO standard indicates, that there might come up to a decision where we have separated standards for material extraction and also the activities. So, for example, we prepare our own cost database and classification system based on the materials that are and work items that are being assigned to the elements. But the other standardized part, which would be the activities during the construction phase, would be part of the separate standard. And this would then be customized based on the either company level or national level or international level. So at this point in Slovenia, we don't have it. If this is the short answer, but we are working on this, and hopefully our project could serve like as a pilot project, or like could serve as a baseline and like a good talking point that this could be achieved. And yeah, if you follow us throughout this project, hopefully we will be able to answer you more precisely and give you the answer that you're looking for.
Right. Thank you, Jan. And there was no other questions at the moment, so we'll wait for some if they'll be at the end. However, Jan, you know, I'll have one for you.
Regarding my model career, or
this one is actually from ChatGPT, and the question is, why did BIM technicians quit their jobs at the construction sites? Do you know that one?
no.
Because they couldn't handle, you know, the concrete details. So with this one, thank you, Jan, very much. And I'm inviting now George. George Tersanos is a senior researcher and a member of Service Technology and Economics group at the Athens University of Economics and Business. He's in the Department of Computer Science, and his research interests include the design of market mechanisms, business models, and collaboration policies in the domain of 5G, 6G networks, cloud computing, and next generation internet ecosystems. His latest research endeavors involve the design of blockchain-based mechanisms for trusted IoT data exchange and decentralized management service provider federations. So with this, George, you are really warmly welcome, and please tell us some more about the frameworks for development of sustainable business models.
I hope you can hear me and see my screen. Thank you, Katja, for this really nice introduction. Today I'm going to present, as Katja introduced, a framework for the development of sustainable business model. This is a framework that has been developed by our team in Service Technologies and Economics group, and brings together, let's say, several standard business modeling methods and concepts, and defines a systematic approach on how alternative business models can be defined and quantitatively assessed in complex or emerging ecosystems. And one important part of this framework is for the implementation of this framework is the 360 business modeling evaluation tool that has been developed by our group and automates all the procedures and steps of the methodology. So to start our presentation, the question that we should first answer is, what is a business model? There are several definitions in the literature. The most commonly used definition is the one given by Osterwalder, and it says that it is the rationale on how an organization creates, delivers, and captures value. Alternatively, we could say that is a strategic plan on how an organization can successfully operate and conduct business in order to generate profits. Besides the economic focus of business models, there is an increasing emphasis on how business model can contribute towards values of sustainability, like the Sustainable Development Goals that have been defined by United Nations. And this sustainability business model could target to energy consumption reduction, energy efficiency, reduction of emissions, innovation, economic growth, and several other targets that have been set by different bodies. And one other important direction for business models is that currently, and especially in technology-enabled ecosystems and in the digitalization era, the business models are moving from the traditional value chain-based business model to, let's say, more value network ecosystem business models where the services, products, and value is co-created by multiple stakeholders and delivered to the customers. So we have a lot of stakeholders, let's say, forming communities or platform offering services. And in such scenarios, the business models of the different actors are interdependent. So when defining this business model, each of them should take account of business models of the others, and it is sometimes challenging to find a situation where all the participants have business models that are profitable. So this is what we are trying to solve with this proposed framework. To start with some basic terms and concepts that we use in our framework, and to build, let's say, step by step. A stakeholder is a party that holds an interest in a specific ecosystem. This could be the construction ecosystem, and more specifically the BUILDCHAIN project ecosystem. And then an actor is a party that actively participates in the ecosystem by consuming or contributed services. Each actor in this ecosystem may adopt one or multiple roles, and with each role focusing on specific activities and contributing specific types of services. Maybe here we can have an example of actor roles in the BUILDCHAIN ecosystem to better grasp what we mean. Probably we could define a role of building manager. Of course, we have some roles, the roles of architects and engineers. We could define the roles of suppliers, contractors, and of course, what is quite relevant for our project is also that we have some technology providers where we can position the solutions of BUILDCHAIN. Then we have the business relationship. A business relationship identifies an interaction between two roles and usually identifies the provisioning of a service from one role towards another, and on the other hand, a compensation towards the other direction. So to give an example here, architects offer design services to building managers, and the building managers pay a compensation for the service that they receive. Also, we can also define other relationship like structural services offered by the engineers to building managers. And so now we can define what a value network is. So a value network illustrates all the roles that appear in an ecosystem and the business relationship among them. So if we go further, we can define some business relationship between technology provider and building manager. We can say that technology providers offering smart building services to building managers, for instance, services related applications or services that enable the energy efficiency of the building, the energy efficiency-based management, let's say, of the building, or technology providers who could also offer service to architects and engineers, like design and structural analysis tools. And of course, we can go forward to define several business relationships in the ecosystem. And of course, depending on the case, we can define more roles, or even, for instance, technology providers who could probably broken down in more specific roles. But for the purpose of this illustration, we keep it simple here. And after having defined the value network, we need, this is a good starting point for having a complete view of the ecosystem, but we have not yet defined the business models. And what we need to do is to use a commonly used method, which is the business model canvas, which is a strategic management template where we can identify which defines certain fields or segments that should be filled by an expert in order to completely define the business model of an actor, and based on the roles that adopts in the ecosystem and on the value network. So the fields contained in the business model canvas, one of the most important ones is the value proposition, which is where we define what is the value delivered by an actor to its customer based on the service and product offerings. So if we assume that we have a technology provider here, actor that offers, as we said earlier, an application for the energy efficient management of the buildings, we can see building energy efficiency as a value proposition here. And or even another example could be the effective proactive maintenance of buildings. Another set of inputs of the business model canvas are related on how these services are delivered, and involves the key partners of this actor that provide some sub-elements of these delivered services, the key activities of this actor, and of course key resources that could be tangible or intangible resources. And another important set is what is the targeted customer segment, and how these services are delivered to the customer, through which channels, and with which type of customer relationships. Last but not least, we have to define the cost structure. What are the different elements of costs for providing the certain services defined in the business models, and of course identify what are the revenue streams that occur from the targeted customer segment. These are the standard, let's say the traditional inputs in a business model canvas. But as I said recently, we have an interest on societal and environmental impact, so we should capture what is the cost and benefits on this matter. So following this methodology, we can define a value network with all potential roles and all the actors adopting some of these roles in the value networks. And then for each of the actors, we can define the business model canvas. However, as I said earlier, in some cases, we may need to examine alternative business models, either compare traditional business model to new ones, or in emerging markets where the business relationships are not well established, we may need to examine different configurations of the business models, different alternatives. So we may need to define different, let's say, instances of the business models. And then after defining all the different instances, we need to set up a procedure on how we evaluate and assess the sustainability of these different business models based on economic KPIs that used in this domain. Some examples are the total cost of ownership, the internal rate of return, payback time, etc. So for this sustainability assessment part, I will give you some more details in this slide. So having defined the business model covers for each actors, as we said earlier, we have the cost structure and the revenue models, but when this gives us, let's say, a qualitative view on the business models, but when we want to quantitatively assess the different business models, we need to do more. So we should complement this with certain cost and revenue models. In the cost models, we should identify the different cost items related to the provision of service and the different cost drivers. What is interesting to say here is that, seeing the presentation of Jon, the previous presentation, I can see that probably this 5D BIM could be also used here as an input, but this is something that we will investigate going forward in the project. And of course, beyond the side of the cost, we should also define models about the revenues, what are the different revenue sources, what are the different prices or the demand drivers, etc. After defining these models, we should provide inputs to these models with figures for the different cost items, and of course the cost drivers, and the same for the revenue model part. Based on these inputs, these models will estimate the cost and revenues. And what we would like to see as an output is that each actor generates a profit. So in such a scenario, with each actor in the ecosystem generates a profit, we can say that we have a sustainable ecosystem. But in some cases, some of the actors may not have profit. So there we may need to apply mechanisms on top that compensate the actors that are not profitable and make the ecosystems sustainable. In some cases, this may not be possible. So in this scenario, we can say that an ecosystem under a certain set of business model is not viable. So in order to, as I said earlier, in order to automate all these steps, and in order to examine all alternatives in an automated manner, we have developed the StackOn 360 business model evaluation tool, where we can evaluate the different business models of individuals and individual actors participating in the ecosystem. We can also perform a holistic cost-benefit analysis for the whole ecosystem and determine whether it's sustainable or not. And of course, we can evaluate whether certain deployed solutions could be replicated to other location or upscaled. These are some of the benefits of the business model evaluation tool. As I said, we can analyze highly complex ecosystem, compare standard business model against new ones. And one important capability of this tool is that can identify and extract business model configuration where all the actors win. So in other words, can identify which business models lead to all win situations. As I said earlier, in this tool, we should provide inputs for different cost items, revenue stream, etc. Some values, for some values, we may not have a precise knowledge. So this tool allows us to perform a sensitivity analysis on certain values, and of course automates certain tasks and is fully customizable. This is just to show you how the dashboard of this tool looks. As you can see, it has several. This is an Excel-based tool with buttons that leads you on different spreadsheets where you can define the different cost elements, drivers, etc. Define the business model canvas, the value networks, all the methodology steps we have described earlier, and to perform the actual evaluation. And now, after showing all these different parts of the methodology, I would like to show you a case study we have performed on the domain of 5G and connected to automated mobility, just to show you what kind of outputs we can have with the analysis based on 360 BME tool. So in this scenario, we assume that we have 4 car manufacturers that offering connected automated mobility services on top of 5G. We have 3 mobile network operators, each of them having 33% share of the market, and we have 1 road operator. So our intention here is to examine 3 different configurations on how the business models of these ecosystems are formed. So the first option we investigate is that we have the independent MNO scenario, where each MNO deploys its own network along the entire highway. And in this scenario, we have the road operator upgrading the roadside units to support this connected automated mobility services, and leases land to the mobile network operators for deploying the 5G antennas and MAC nodes. A second option is to have the MNOs collaborating and deploying their 5G network on different parts of the highway. So this is, let's say, 1/3 of a highway, for example. And again, in this scenario, the road operators follows the same strategy as in option 1. And finally, in the third option, we have the MNOs deploying only the active part of the 5G networks along the highway. And the road operator acts as a neutral host by renting 5G equipment and deploying it on the side of the road as a passive infrastructure, and offer also backhauling services. So for each of these business model configurations, we define some the costs for each of the actors. We have, you can see the different actors with different color. And here you can see, for instance, for collaborative MNOs, the cost items are the same, but their values is lower because they only serve, each of them only serves the 1/3 of the road. And for the passive network case, you can see that the road operator has a greater cost because it deploys the passive network part of the solution. After defining the different cost models here, we feed with some inputs our cost model. I will not go into detail here, but what I wanted to mention is that we consider three different scenarios in terms of the demand, which means the number of cars that are going through the highway. And also we consider two alternative cases on how much the road operators charge the mobile network operators for deploying their infrastructure on the roadside. So for each of this configuration and for all demand cases, we evaluate the business model based on the 360, using the 360 BML tool, and this is the output. And we can observe here that the road operator and service providers generate profit in any of the cases. However, for mobile network operators, the business models of independent operation and passive network are not viable. So in such scenarios, the ecosystems are not sustainable. And we can see that for medium demand, in the MNO collaborative business model, we have a profit for the mobile network operator, but the internal rate of return is low. So the MNOs may not want to invest in such a solution. And the only case that someone would say that the operator would like to join such an ecosystem is when the demand is high. So we can see that only one of the three considered business models is sustainable. And of course, not in all cases, only for high demand conditions. And here, what we could do is that if we assume that the road operator asks for a reduced rent for the lamppost from the MNOs, so we can see this case that the MNO collaborative business model becomes profitable for medium demand and for low demand as well. So this is a measure on how we can render a non-sustainable business model in a more sustainable business model. This is just to show you that the 360 BML can produce several outputs for different economic KPIs and in different forms of representation. This shows what is the payback time of the investment of MNO in the span of 10 years for different demand scenarios. I will not stay in this slide for more. Just to conclude the presentation is to say that in BUILDCHAIN, we will develop and evaluate alternative business models that will enable under certain conditions the establishment of a sustainable ecosystem around the DBL services, and of course establish a new healthy economy around these services. And what we expect is that these services will cover aspects like energy efficiency of buildings, structural health monitoring and proactive maintenance, improved management, deeper innovation, etc. That's all from my side. Thank you for your time, and sorry for going a bit over time.
Thank you very much, George. No, you were great, no problem there. But we are waiting for some questions. So, you know, George, it's your turn now. For the moment, there are none from our listeners. So I'll just, you know, ask you something this time. You know, why did the entrepreneur need the business model canvas? I read that book too, so it's a great book for value proposition defining. But here it's a joke, so any ideas?
No.
I'll just track you with the answer, because they couldn't afford, you know, the business model all painting, therefore they just went with the canvas.
A good one. Thank you.
Okay. So in the meantime, we do have one listener with a question. Tinkara Kopar from ZAC poses a general question. Is there already a database of construction products with their characteristics and prices established for the purpose of BIM modeling? Is there any coordination at EU level on the construction product database, specifically in relation to a new proposal of EU regulation for construction products, which is being prepared at EU level and in which an idea is included to set up a database of construction products with information from declarations of performance, CE marks, declaration of environmental parameters, that's EPDs, and various instructions on and so on. So I don't think George is the right person to answer that. Could you answer it anyhow?
Yeah, I think there are a lot of questions. I'm not sure I'm the person that should answer this. I'm trying to track any of these probably that I could answer. Let me check.
So the main question is if there is any common available EU database with all these data, and I'm not aware of such one.
Me neither, me neither.
Right. Tinkara, we will ask around in our project partnership, and provide the in-depth answer to this complex question over the email. Any other questions? So the proposal is that for now we stop recording this webinar and open the panel for a discussion, for any comments, maybe for the participants to express their valuable experiences or opinion. So everyone's really warmly welcome. And
maybe before we start this session, I would like to promote our next webinar, which will be in 2 weeks. We will advertise that soon. And actually, Katja will present on this webinar, so I'm sure you will all enjoy this next webinar. We will keep on talking about sustainability issues, right? And also how to enforce sustainability ideas and energy efficiency and so on. So please follow the social media platforms and join this following webinar as well.
Great. Thank you, Noemi, for this kind invitation. For sure, we'll be together, right? These webinars are fun. So I will thank you all for being with us, participating. And for now, we will stop the recording, and you are still very welcome to stay if you want to and join the discussion.